In section 7.1, we're going to start talking about exponential functions. And first, we're going to start by graphing exponential functions. So until now, we've learned how to graph linear functions. We've learned how to graph quadratic functions. We learned how to graph square root functions, right? And now it's exponential functions. So let's talk about what exponential functions, where they're used, basically. All right, so suppose, after a long weekend, right, you haven't seen your friends in like, oh my gosh, like 3 days, right? You come to school and you're just like, oh my God, I missed you so much, as one does at our school, right? And you're all like hugging and everything, and your friend, is like coughing while you're hugging them, right? And so you're just feeling all fine in the morning. By bonus, you're just like, oh my God, like I feel like a little tickle in my throat. By lunch, you're feeling weak. There's like, right, something definitely happening. You go home and you just want to get into bed, and by night, you're just done. Right? And you remember, oh my God, in the morning and during that hug fest, right, so and so was coughing. So they must have been sick. You went to school feeling just fine. There was none of that virus in you. But as they were, coughing all over you, a little bit of that virus, a couple of cells happened to land on you. And within a short amount of time, by bonus, by lunch, by the afternoon, they've now multiplied to incredibly high amounts. That is exponential growth. An infection. The spread of an infection, a very high amount of growth, a very big growth in a very little amount of time, in a very short amount of time. So this is what an exponential growth function looks like when you graph. So if we pick, 1 point here, this is the x value, right? So here. And then suppose I go over on the x-axis just by a little bit, and I go up there. That's the point, right? So take a look at how little I went over in the x-axis, but take a look at what a big change that produced over in the y-axis. That is the big characteristic of exponential functions, just rapid growth. Now, at the beginning, could you say rapid growth?
Rapid growth on the y or the
along the y, just goes up very, very quickly. So now, at the beginning, yes, you didn't have any of the virus on you, but could you really say you had like zero amount? Not really. So here at the bottom, it goes very, very close to zero, but never really touches it. We call that concept an asymptote. An asymptote is an imaginary line that the graph comes very, very close to, but never touches. All exponential functions have a horizontal asymptote right there. It's drawn with a dotted line, and it's a line that the graph comes exceedingly close to but never touches. Anytime you draw a graph of an exponential function, you've got to draw the asymptote, right? So let me tell you something else. If I were to ask somebody to draw a bunny rabbit, right? Now, if somebody asks me to draw a bunny rabbit, I can't draw to save my life. I can't draw a thing. But, okay, what I would do is maybe draw a circle. And what would you put on there to make sure that somebody knows it's a rabbit that you drew?
ears.
The ears. That's what is the characteristic. Asymptotes are that same idea for exponential functions, right? You cannot draw an exponential function without a horizontal asymptote. Okay, here are some more things to keep in mind. When you have the graph of an exponential growth function, the way you know it's growth is because the graph moves away from the asymptote as x approaches infinity, right? So as x approaches infinity, as you go further and further to the right, the graph moves away from the asymptote. It can move up away or it could move down away. All right? That's how you know from the graph. How can you tell from the function? What does the function of an exponential function look like? This is what it looks like. F of x is equal to b to the x. So for the first time now, I'm going to have, the number as the base and the exponent as the variable. Okay. Now, if you have the function, let's go back in this box. The way you know that this is growth is because that number b has to be greater than 1. The one that has the exponent has to be greater than 1. Okay, here's what you absolutely need to memorize for exponential functions. The domain is always all real numbers. And for the range, you always have to connect it to the asymptote. So it's either going to be y is greater than the asymptote or y is less than the asymptote. Okay, so enough of that. Let's see how we can graph one. So first I have y equals 2 to the x. First of all, let's determine, is this exponential growth or decay?
Do I put in the calculator?
No, just by looking at it, look at this number. Is this greater than 1 or less than 1? Greater than 1, so this is growth.
It's like as y approaches positive infinity,
X the other way. X approaches positive infinity. The graph just moves away. Okay, it just goes either really high up or really far down.
But if it goes really far down, it's negative.
Right, but it's still growth because it's moving away from the asymptote. Okay, so now go down here. For the asymptote, for the default case, the asymptote is always going to be y equals 0. You can't just say 0, it has to be y equals 0. Domain is always all real numbers. These things you should be able to do just like that. Yes, for the default cases. So like for this one. Okay, now we're going to graph this. To graph this, we have to pick points. These are really good points to pick. -1, 0, 1, 2. So we're going to plug these in. 2 to the power of -1. All right, so go ahead on your calculator. 2 to the power of -1 is 1/2, right? So this is going to be 1/2. 2 to the power of 0, what's anything to the power of 0? 1. 2 to the power of 1, 2. 2 to the power of 2, 4. Okay, now let's graph this. First, you put in the asymptote. Now, with my pen, right, I can do it right on the axis, but I get it. With your pencils, it might not show, so it's fine to go just a hairline above. That's totally fine. Okay, let's put in these points. X is -1, y is 1/2. X is 0, y is 1. X is 1, y is 2. X is 2, y is 4. Now, let's connect. Okay, this is not a good graph because this is connect the dots like you were in kindergarten. You have to show me that on this side it follows the asymptote without touching it. Just comes really close. And you have to show me that this goes really high up. Okay? So now.
Do we have to draw the little dotted line?
Yes. That's the asymptote.
Wait, what?
Huh? The red line. Okay, the y-intercept. The y-intercept is when x is 0. So come over here for when x is 0. What was the y? 1. So we say 0, 1. Okay, the range. It's always going to be y and then whatever value the asymptote was. If this is 0, that is 0. Now, look over here. Is this above the asymptote or below? Above means greater. It's always the same as the asymptote. For the default cases, it's always 0. Until I tell you when it changes, it's 0. Okay?
What was 0 again?
The asymptote. The asymptote is
bottom line
y
is
equals
sometimes
0.
it's going to move on the graph.
Right. Okay, so let's move on to another one. Okay, exponential decay. So now, remember how sick you were feeling? Your parents say, you know what, we got to go to the doctor. So you go to the doctor, they take one look at you, they go, this is not a virus, you have strep throat. So they give you antibiotics. You take one pill, you take two pills, and all of a sudden, you're feeling so much better. That means all that bacteria that was inside your body, just as quickly as it increased, they now decayed or died away. So they started up at a high number and then eventually went down to 0. So here, the asymptote is right over here. And we know that this is decay because as x moves to positive infinity, as you go further and further to the right, the graph moves toward the asymptote. Okay, so
the graph is not going up, it's going down.
It's going towards the horizontal line. Okay, now look. How do you know from the function? Well, it's because that number b has to be somewhere between 0 and 1. So for example, y equals 1 over 3 to the x. That's exponential decay because 1/3 is between 0 and 1. Y equals 0.5 to the x. Exponential decay. Okay.
So it has to be a fraction, but like less than 1.
Between 0 and 1. Yeah, so
But
like
if it's 1, it's not.
no, 1 doesn't even work. Okay, so but it's like 5 over 2, it doesn't work. Okay. All right. So domain is all reals again. Okay. So here, is this growth or decay? Decay. Right? Okay. The asymptote is again y equals 0. The domain is all real numbers. The range is going to be something connected to 0. I'm going to fill that in later. Okay, so I put in my asymptote. And again, I put in my points, -1, 0, 1, 2. Okay, so 1/2 to the -1, you put it in your calculator, what do you get? 2. 1/2 to the 0, what is that? 1. Okay, and these we know, 1/2 to the 1 is 1/2. 1/2 squared, 1/4. You can also plug those in your calculator. Okay, which one of these here is the y-intercept? First, second, third, or fourth row? Second row. This is the y-intercept when x is 0. So y-intercept, 0, 1. Okay, let's graph these. -1, we're at 2. 0, 1. 1/2. 1/4. All right, do you see how it's decay? Because as you move further and further to the right, it's moving closer and closer to that horizontal line. Range is y greater than or less than 0? Who says greater?
Less.
Okay, why less?
Because it's going down.
But is it, okay,
It's above.
it's above the asymptote. Because it's above the asymptote, it's greater than 0. Yes, right? Because all of the y values are bigger than 0.
Is it possible to have
Yes. Mm-hmm.
Oh god. Oh yay.
Yay!
No.
Okay, so transformations. You guys remember when we had like y equals x squared, and then we had y equals a, x minus h squared plus k, and each of those do something? Same thing. So this number h, what does h do? It's the horizontal translation. What does k do? Where? H shifts it left, right? What about k? Up, down. So that's the vertical translation. Okay. Now, vertical translation. So k moves the graph up or down. When the graph moves up or down, everything associated with the graph also moves up or down. That means the asymptote moves up and down along with the graph. So when we have a plus or minus k, the horizontal asymptote is going to be y equals k. That's how it changes. So that's when it's no longer y equals 0. It's y equals 4. Now, what does A do to the graph? So A is, what just happened here? Right? So A is vertical stretch. But more importantly, if A is less than 0, what does that do? Reflection. So it's vertical stretch or compression. Okay. If A is greater than 1, it's a stretch. Okay. So here we have 2 to the x minus 2. What shifts have there been to this? What changes have there been to this? Vertical shift. So it moves down 2. Is this growth or decay? What is it? Why growth?
Oh, because it's a 2.
Right. It's 2 to the x, so it's greater than 1. So it's growth.
So does that make negative 2?
Yeah. Right. So here, okay. What is the, all right, so let's go down here. What is the asymptote here? The horizontal asymptote. Okay, but we have to say y equals negative 2. It's this number. It's horizontal asymptote. Okay, so we have to pick some numbers here. -1, 0, 1. Okay. This time, however, okay, let's put in the asymptote first at -2. Oh my God, guys, that's horizontal asymptote, h dot a. Okay. Okay, so listen. This time, here's what we're going to do. So you first put in the horizontal asymptote. Now here's what we're going to do. What is the domain for this, by the way? All real numbers. Okay, so go to your graph, and we're actually going to graph this. So we're going to say 2 to the power of x minus 2. Okay? Now, do Control T.
Growth.
It is growth, yes. Control T. At -1, this is -1.5. Right? At 0, it's -1. 1, it's 2. Okay, do you see how you can do that very, very quickly? So, -1, -1.5. 0 minus 1, 1, 2. Okay. Range. It's going to be y compared to the asymptote of -2, right? The same number is that same number here. Is this greater or less than, though? Who says greater? The range, is it greater than or less than -2? Greater than or less than? Greater than -2. Yeah. Okay. All right, so let's do the next one. Okay. Horizontal asymptote. What's the horizontal asymptote? Y equals -4. If you just say -4, it's -1 right off the bat. Okay, and the first thing I do is graph that. So now, here, is this growth or decay? By the way.
Growth.
Okay, how do you know?
Negative.
Find the exponent. It has nothing to do with negative or positive.
It's
Find the exponent. Where's the exponent? Here. What number has been raised to the exponent? 3. If that 3 is bigger than 1, it's growth. Okay, so growth. So, -1, 0, 1. Okay, these numbers that I'm picking, it's not like the law that's all you have to pick. But, you know, with exponential functions, numbers get really big really fast. So, you know, I mean, I could pick 154 if I want to, but just pick whatever works for you.
I can pick whatever I want.
Mm-hmm. But make it like reasonable so it doesn't go too far off the graph.
So if I wanted to do like 1, 0, 1, 0.
It could be anything you want. Yeah.
So the growth or decay is based on
Not the coefficient, the base. It's called the base of the exponent. 3, the 3 here. Yeah. Okay, so yes, but let's do this first. So 3 to the power of x plus 1. So I just erased the function, and now I'm graphing the new one, and when I press enter, it'll replace. See? Okay, so Control T. -1, we're at -3. 0, what was it? -1, and 1 is 5, right? You should always pick x equals 0 because that's the y-intercept and you want to have that number. So -1, -3, 0, -1, 1, 5. So, okay. All right. So domain, all real numbers. Range, you compare y to the -4. Greater than -4. Okay. So take a look at the next one. Is that growth or is that decay? Decay. Okay. What is the horizontal asymptote? Aha, finally, y equals 3. Good. What about this one? There is a reflection, okay? So y equals 3. Okay, we're going to pick -1, 0, 1. What's the domain? Okay, so go ahead and graph this on your calculators and draw the graph. On your mark, get set, go. Huh? No, just do this one. So, don't do D yet. So, this is... Okay, so what did you guys get for x equals -1? Right, so -1, and then for 0, and for 1, how much? Okay, so, right, so -1, -1, 0, 2, and it looks like this, right? Okay, so y is less than 3 is right. Okay, so this is decay, right? Do you see how as you move far to the right, the graph is approaching the horizontal asymptote, right? So that's the same. This is just a reflection of it. Okay, what about this one? Is this growth or decay? Decay. There is a reflection, right? The 4 provides a what? What does the 4 do? A vertical stretch. And what is the horizontal asymptote here? Y equals 5. Okay, so y equals 5. Okay, domain is all real numbers. For the range, look up here for a minute. We're going to compare to y is 5. Now look. Do you see how this is a reflection? This is a minus in the front. Whenever it's a minus, this is always going to be less than 5. Of course, you can also tell after you graph, but that's also a very quick way to figure that out.
So if it's a reflection, it's less than.
If it's a reflection, yeah, if there's a negative in front, this is going to be less than the asymptote. Okay? You already know. Yeah. Okay, so now go ahead and graph this, please.
For -1.
It's what?
How do you fill out the graph?
Let's see. We'll pick a different number, right? So this is -4. Okay, so this is what this looks like. So let's see if I do Control T. Okay, so for -1, it's -11. Okay, so I don't have to pick that one. So I pick 0, -3, right? And what else? Right. 1, it's 1. 2, it's 3, right? So this is what I mean, is you have like full freedom to do that. So 0, -3, 1, 1. Okay. So that's how that goes. Okay? All right. Okay, and that's where we're stuck. So the homework is a worksheet, and I'll put it online as well.